So hello, my name's Charles Purkess. I'm Business Development Manager for ITM Power. I cover two regions really, the UK and also Australia. So I'm a director of the subsidiary set up in Australia in 2018. I've been with ITM since 2008. The company was incorporated in 2000, and so I've seen it travel quite a long way in terms of its development, both its products, but of course the market and how it's aligning itself to position itself to be in the sweet spot for this global requirement for electrolyzers. Positioning for green hydrogen growth. This is a perspective from ITM Power. It's a UK company based in Sheffield. And it's a global leader in the design and manufacture of rapid response PEM electrolysis. And this is a type of electrolyzer system, we call it, that integrates with renewable energy and converts renewable energy to green hydrogen that we need for decarbonizing industry and processes the electron can't reach. As a company, we've been positioning for this very large global market that's emerging due to the net zero, the outcomes of COP26 in particular, and the need for standardized products that can be sold around the world that are at the right stage of technology development in terms of commerciality, but also scale and viability. And in order to do that, we have built last year, the world's largest factory for PEM electrolysis in Sheffield. It has a capacity of 1 gigawatt of electrolysis per annum in output. And we've raised funds to expand that to 5 gigawatts, with 2.5 gigawatts being manufactured in the UK and 2.5 gigawatts being manufactured overseas. For net zero, and for achieving those requirements for carbon reduction, electrolysis and making green hydrogen is absolutely essential. It's a real key technology. And what I'm going to do is explain a little bit about the technology, the products, and how we've positioned ourselves to collaborate with partners and to excel into the global market. So what we make is this box in the middle. What that does effectively is take water, H2O, and split it into hydrogen and oxygen via electrolysis. And we can do that using renewable energy, the wind or solar or tidal. We don't mind what the electrons are. And by splitting that water, we are creating another energy vector, hydrogen. Hydrogen that you find in all fossil fuel, but is normally packed by carbon and other noxious substances. When we make it from water using renewable energy, we call it green hydrogen, and it has a totally carbon-free footprint. And it can be used in those processes and industrial sectors that traditionally use fossil fuel as the ingredient for its process. And traditionally, hydrogen market is very large, but hydrogen comes from steam reformed natural gas. If we're making it from renewable energy, we can displace that natural gas and need for natural gas and the carbon methane requirements that cause so much global warming damage. So the hydrogen has applications across industry, from ammonia, chemicals, reducing agents, for refineries. And then you have other applications where you're using the hydrogen to substitute methane in heat and fossil fuel in transport. In addition, the electrolysis systems are rapid response. They can provide grid balancing services. They can turn up and down in under a second and provide the stability via grid balancing on frequency on the transmission networks and voltage stabilization on the distribution networks, so enabling more renewable energy to be planted on the grid. It's a perfect energy storage solution that doesn't require investment in energy storage capacity. The market is huge, and the International Energy Agency has stated we need 3,500 gigawatts of electrolysis by 2050. And there are initiatives by countries, regions, and across the world in terms of committing to electrolysis. So it's a very, very large global market, and we're a leader in what we do. This is our 10 megawatt electrolyzer in Germany, at Shell's refinery in Cologne, and it was the largest electrolyzer, PEM electrolyzer system deployed in Europe, and it enables Shell to use the hydrogen for desulfurizing their process, but it's just a very small demonstrator. Shell have just committed to working with us to expand that to 110 megawatts to enable the production of synthetic aviation fuel that will be essential for decarbonizing flights in the future. And so we've been positioning in terms of leading on the scale up of the technology throughout the years of product deployment. From our network of hydrogen refueling stations that were 100 kilowatts, through to the first power to gas in Holland, Netherlands, which was a megawatt, through to the Shell Refine project you've just seen, 10 megawatts, and the 100 megawatts projects that we're working on, both with Shell and with others. And we have front-end engineering designs for very large-scale electrolysis now. And the reason we can do that is through collaboration, and in particular with Linde, who took a 20% stake in ITM Power. So we have equity investors like Snam and Linde, and then we have renewable energy development on the commercial development partners, and the likes of Shell and Sumitomo for the Japanese market. And what is key is EPC, having an exclusive arrangement with an EPC partner that enables us to provide turnkey green gas solutions, from electrons in to the product out. And we were able to do that through a partnership with Linde Engineering, and we formed the joint venture ITM Linde Electrolysis 2 years ago. And what that enables us to do is to deploy these very large scale products and focus on the technology, but provide all the engineering, procurement, construction, and the portfolio of downstream technologies for making ammonia, for cryogenically storing hydrogen and oxygen, which is another byproduct of the process, and all the logistics and other aspects for the plant and projects. So when you're looking at ammonia project, for instance, there's a huge amount of different plant. There's the electrolysis, there's the Haber-Bosch process, and the logistics for transport. And these are the type of thing we can do under one turnkey offering. This is our factory in Sheffield. It's enormous. It's the size of 2 football pitches. But in it, it's not just the size, it's the technology within it. And we've been designing and developing our stack architecture to enable us to use low-cost components and bring in semi-automation and full automation of the stack development processes. Here is an example of our products. On the right, we have containerized products, and below you see large-scale 100 megawatt deployments that we've been designing. And this is our core technology. It's the electrolyzer stack. We're a vertically integrated manufacturer, so we design the electrochemistry, the catalysts, the membranes, the stack, and we've evolved that stack architecture in a way that we've proven it in the field at various scales, and it's suitable for upscaling, which is key. And that's one of the reasons why Linde Engineering invested in ITM Power, because we have a low risk route to scaling up our electrolysis systems and can make them at the right cost and have very large production facilities. You'll see below there, our backlog is 300 megawatts and our tender pipeline is about 1 gigawatt. 2 years ago, our tender pipeline was 300 megawatts. The industry is moving very quickly, and in fact, the figures are going to be very much exceeded in the near future. So just to summarize, this is ITM Power. We're a leader in PEM electrolysis, the ability to convert renewable energy to renewable fuel in the form of green hydrogen to decarbonize all those sectors the electron can't reach. We're a leader in the technology, a leader in the scale of manufacturing, and a leader with turnkey solutions through our exclusive partnership with Linde Engineering. And we have collaborations in terms of renewable energy producers, as well as the oil and gas industry. We've raised funds. We have $250 million that we raised 2 weeks ago as in our arsenal to expand that manufacturing and to deliver that growth of 5 megawatts per annum by 2024. So thank you for listening. I hope this has been useful, and thanks.